Yo, what's up, Raiden, dude? BRB, he says. Okay. All right, dude. Let's make sure my audio is working okay. Test. Yep. All right, good. What's up, Obama? Good to see you, dude. You are first, dude. Congrats. First, dude. First. What's up with my headphone thing all the way over there? How was your guys' weekend? You have a good weekend? Okay. Was it okay? Mine was a pretty long weekend. I had to fly to Houston on Wednesday. I flew Wednesday night at like midnight to Houston. I got into Houston at like 6 o'clock in the morning, so it was a red eye. And then I streamed for you guys. I have to pay $90 to repair my phone because my mom broke it. Oh. Why do you have to pay it if your mom broke it? Is she not going to pay it to fix it because she broke it? Is that not how this works? Yeah? What, you need a new screen or what? What happened? I need some lights in here. Ooh, I need to stream. That's right. Yeah, thank you for reminding me. I do need to stream in the Discord. I always forget to do this. There we go. Now it's streaming. What's up, Habibs? Is Dr. Gold talking? I am talking. Can you hear me? I was going through some of the messages in the Discord. You can't hear me? No? Really? I think you should. Okay, you can now. Okay. All right, good. Good. Bruh. Bruh, what, dude? First as always. Mechanical, you're third. I can't hear him, but I think it's just my volume. Yeah, Obama was first. Yeah, turn your volume up if it's not. I'm trying to set all the volume levels to be equalized as much as they are, but like sometimes those mess up, you know. We had a lot of people playing in the Jackbox games over the weekend, which is fun. And we had that debate game, the Let's Argue. I think you guys had a lot of fun debating about whether Fortnite was better than Warzone. 2 dubs today. I saw that, dude. With that sniper dubs, dude. That's pretty sick. Yeah, what is this about it being the new chapter? I see it's like there's something that's like it's like an upside down world. There's like two worlds now like in this big bubble. Three to four third places. Oh, that's still pretty decent though, getting third place. Tons of cool stuff. Yeah, well, they got to keep it. Dude, I'm excited. Warzone has a new map coming out on the 9th, so in 3 days. A whole new map called the Pacific, which is pretty cool. So, have you guys seen the trailer for it yet? Looks pretty cool. Let's watch it real quick. Yeah, this just came out. Just came out today. Let's see, maybe full screen. So it's a pretty new map. I like it. It looks beautiful, at least. And then they got the Jeeps, and now I guess apparently we're using planes. Like you get to fly planes and stuff. That's pretty dope. Yeah, it's kind of like it's an interesting blend between like World War II and like not World War II. Also, like, what's the point of this iguana? I was like, does that get to be like your one of your finishing moves? Is like a giant lizard just like kills the person? But it looks like they're gonna have looks like a lot of planes in here at least. Like, oh, this is definitely World War II. Then what? Yeah, we're gonna have like aerial dogfights now. Yeah, this is the new Warzone coming out on Thursday. So that looks pretty cool. I don't know. I'm excited that we'll have a new map finally. The iguana is actually a pet? Oh, wow. So, like, wait, can you use the iguana as like your assassination move? It boosts your morale, dude. What? Yeah, I bet it does. Oh, it is. Oh, yeah, the iguana is an assassin, dude. Oh, man, that's cool. Okay. All right, that's dope. I'm about this, dude. You're gonna have PETA or something, like, being all up in arms, being like, yo, what? Yeah, the unlock. Yeah, some people, you can buy unlocks or something. Yeah, I've seen this. Nice. Good you got your V-Bucks. Yeah. I gave out V-Bucks to Cypher today, or I bought his battle pass because he wanted it, and he won it by getting enough channel points. You got the emotes. Yes, bro. Did you add some new emotes to your Twitch? Yeah. Let me see them. What'd you do? GG, Salty, Lol, Patrick. Oh, yeah, and the SpongeBob meme. That's a good one. 200 IQ. Yeah, that's cool. What's up, Graham? Good to see you, dude. How come I don't hear anyone in Discord? I guess, is there anyone talking in Discord? No one's in the Discord. Okay. Obama is your first sub. Yeah, I saw that, dude. That was over the weekend. I saw that. While I was in Houston. Congrats, dude. Yeah, dude. Mechanical, you're on the way, dude. On the way to becoming a pro streamer. Nice. Okay, cool. I was also streaming Fortnite while... Yeah, I saw you were streaming Fortnite. Yeah. I think I was at the wedding while this was happening. Dr. Gold, when do I get mod? Ha ha ha! You You get mod when I feel like you've earned being a mod. That's how it works. You're doing very well, Habibs, though. You can be you can ask Mechanical to be a mod in his Twitch. Like that's totally cool if he wants to, because you know a couple of you guys have already demonstrated that you're pretty trustworthy and able to do stuff. So you could definitely be mods in his Twitch. Habib is Mr. Mechanical's best friend. He's always well. I mean that's good. You know, no, that's dope.
That's dope.
I want you guys to all be friends. That's kind of the whole point, right? Is for you to have a community that you can meet new friends and, you know, play games. Yo, what's up? What's up, Jack? How's it going, dude?
I barely can hear you.
You can barely hear me? Turn your volume up. Turn your volume up, maybe. Have you tried turning your volume? I don't think my volume's too quiet on the stream, right? Is it too quiet? All right, can you turn?
I got it.
You got it? All right, good. Just turn your volume up. Yeah, because otherwise it clips on my side, and I don't want it to clip for everyone else. What's up, Jack? How's your weekend going? Or how did your weekend go, I guess?
Good.
Good, dude. Nice.
Have you heard the book? Have you heard the book Winn-Dixie?
Yeah, is that about a dog,
Have you heard
right?
the book?
Yeah, Winn-Dixie's a dog, right?
Yeah, and Thor is Winn-Dixie.
Soar is Winn-Dixie?
And the dog was in the. Yeah,
Oh,
we watched
okay.
it today. We was learning it. We was do question.
Uh-huh. What is emo only chat? What are you guys doing in the chat?
What have your week been doing?
My week's been good. I was at a wedding in Houston this weekend. It was for one of my friends that I met when I was probably around your age. I was in middle school. I met this guy. He's a friend of mine. And so I saw a lot of my old high school friends, middle school friends. So it was cool to catch up and stuff.
How old were they?
They're all my age. So I met them when I was probably around 10 or 11, but now we're all in our 30s. We're all like 31 or something. So 20 years of knowing each other, you know. I've known them longer than I haven't known them, I guess. It's kind of a cool thing.
Are you
Am I what?
31.
I am 31. That is correct. I will be 32 in a couple months here. Maybe like 4 months, 5 months. We're not boomers, dude. What? People saying we're...
You was 32.
Yeah, no, I'm... How old do you think I was? That's always a good question.
Guess what's my favorite number?
Is it 32?
Hey, Gold.
Yes.
Guess what's my favorite number?
Is your favorite number 32? Is your favorite number 32,
Guess
Jack?
what's my favorite number?
Is it 32, Jack? We got to get this kid a better internet connection sometimes. What's up, Philip, dude? Good to see you, bro.
I got some chemistry questions.
Thank you. Awesome, dude. As Jack.
Intermolecular bonds and everything.
Nice, dude. Okay, yeah. Yeah, I got you.
I
Dude.
barely could out. I'm freaking out. I barely could hear you.
Oh, yeah, it's okay, Jack.
Hear
Yeah,
me?
I can hear you now, Jack. Yeah, you're good. I think your internet was going out.
Right? It should be enough.
Nice, thanks, Philip. Okay, let me announce everyone here on stream. Welcome to Office Hours. This is the stream. My name is Dr. Gold, and this is the stream where we help you out with that whatever math or science. Jack, I can hear you, dude. I think your internet's going out. It's okay, Jack. Just give it a second, Jack. Okay, my name's Dr. Gold. This is Office Hours, the stream where we help you out with whatever math or science homework questions you have. Test prep coming up. I know a lot of you guys have finals coming up soon here. Yeah.
Like 2 weeks.
2 weeks, right? Yeah, you got 2 weeks. You got finals coming
We
up.
got this week and we got next week is finals.
Okay, cool. All right. Well, yeah, and it's we're closing out the end of the year. It's been a cool cool year the whole time here. Oh. All right. I'll do some quick updates about the monthly tournament real quick. Okay, so you guys have been competing in Warzone. I think we have 2 people that submitted matches. I think Obama, Initial, Nugget, and Grim did. So, reminder, you have until tonight to submit a Warzone match, a Battle Royale match. And if you do the best, everyone on your team gets 3,000 monthly MT coins, which you can then use to redeem for some really big prizes at the end of this month. And then starting today with office hours, we're going to start switching over to Fortnite. So this week will be Fortnite games. If you want to compete and play in Fortnite, come play with us this week. Yes, Jack. What's up, Jack?
What
Yo,
did
Jack, you
just
played the new
say?
update?
I haven't played the new update. Jack, you can't be screaming on my stream, dude.
What did you just say?
What did I just say, dude? I said that we're going to play Fortnite this week, Jack. We're going to be playing Fortnite.
No. You mean we are playing Warzone, right?
No. This week is Fortnite. Last week was Warzone. We switch it up. Every week it's a new game.
No, every 2 weeks.
Yeah, I think I suggested doing it every 2 weeks, but I want to do every week because I want to wait for the new Pacific map to come out so that then we can do a whole new fresh week with Warzone on the Pacific map.
No, hey. So wait, dude, you got like 2 PCs? No,
I do.
No, 2 commanders. I would start your Fortnite up because it takes 10 minutes load.
Yeah, you're right. Yeah, I tried that this morning, guys. I tried loading up Fortnite because there is a new chapter. Yeah, you have to go through a whole thing. I did it, which was kind of dumb. I was like, what? I gotta walk over and like
the
sit
queue
down
is
at a.
gone now.
Oh, they got rid of the queue. Oh, there's no more queue. Okay, good.
Well, because the servers were like overloaded, but now there isn't.
Oh, okay.
When
Yo,
I
Jack.
First, when I first played, everybody was like freaking out.
Oh, were they? Yeah, because it's the new season. Everyone's like trying to jump in and stuff.
Like 7 million people on at one point, which was
oh my
actually
god!
really insane.
Wow, dude. Yeah, Mechanical said he already got 2 dubs in the new chapter.
Queue, so it wasn't that bad.
Okay. All right. Well, if there's ever a long queue like that and whatnot, then we'll just
made
wait.
it. I'm here now.
What's up, Mechanical dude?
Hey,
I've been missing you, dude.
Mr.
What's up?
Let's pull in Philip's question.
Save the word. I still got you some stuff. Okay.
I feel so blessed. Everyone's just giving me stuff.
Dude, you still got some stuff, dude. Nice.
Yeah. Me and who gave you some stuff?
Grim. Jack, I played the new chapter today. I got 2 wins.
Got 2 dubs, dude.
Yeah, I got 4 wins.
Wow.
Quiet.
Yeah, dude. He says he got 4 wins, dude. How you gonna take that, dude?
Played
You got 4
arena.
wins. You got 4 wins, dude.
We don't talk about that. Okay.
Yeah. Okay. Let me help Philip with his questions real quick, and then we can talk more about Fortnite.
Yeah, I'm
stuff.
out. I'm about to be on Twitch.
All right, good. You be on Twitch.
Yeah,
Do
later.
you want me to raid your channel or something afterwards? I can raid your channel. Okay, cool. All right, Philip. What's the questions here? Elements in a bond. Elements with stronger electronegativity. Draw any charges on the molecule.
Like, identify some parts of it.
Some shit here, I guess, right?
Yeah. I'm trying to, like,
okay.
learn the charges and everything.
Right. Or do you have to do formal charge?
No, just like it looks like an S kind of, just plus or minus.
Oh, this. So
Like
no,
that.
you're talking about this, right?
Yeah, that.
Yeah, that's just called sigma, is what that's called.
Sigma, yeah, sigma.
Okay, well these are always like positive, right? Hydrogens are just positive. And then I guess carbon is slightly slightly electronegative. Yeah, exactly. And I mean the reason you know this is because here, let me pull up always need a periodic table.
Always getting the periodic table.
Yeah, I honestly should just keep one of these on my desktop so I'm not having to fucking do this all the time.
And you found like a good one.
Yeah, like a really nice one. Just be like, this is my periodic table for life, dude. Wait, can I pick? No, that's not the periodic table. God damn it. copy the image, please? Thank you. There we go. Okay, yeah, right. So in terms of electronegativity, right, stuff is positive over here, stuff is negative over here, right? And then it's more negative as we go up, right? And it's more positive as we go down. Okay? That's just like the periodic trends of things, okay? So when looking at yo, what's up, Joel from Aztec? What's up? And Danny Yoshi, dude. Yo, Danny Yoshi. I haven't seen you in a while, dude. Nice. Okay. So right. So carbon is negative here. Cool. No charges, partial charges, or full charge. What do you mean by no charges, partial charges, or full charge? What?
Like, it's just asking, is it one or one of the other? You know. Well, there's charges here. Sure.
I mean, overall, this thing is neutral, right? Because carbon, right, is 1, 2, 3, 4.
3, 4, and there's 4, and then hydrogen.
And there's 4 hydrogens, right? So carbon has 4 valence electrons, right? Carbon's got 4 valence electrons.
But since there's 4 hydrogens, also 4.
And then there's 4 hydrogens that each bring an electron, right? So you get like the full octet and whatnot. So everything's neutral here. Nothing's. I don't think there's any charge. I think this is no charges.
And then we did draw the charges.
But then it says draw any charges on the molecule. I'm just like, okay.
Well, we just did the sigmas, and then
okay.
I forgot. Like we went over this a couple weeks ago, but I kind of forgot.
Polar, non-polar. Yeah. Okay. So polar means that there's something that's not balanced. For instance, like it's not symmetrical. Okay. So.
Oh yeah. Okay.
Right.
So it has to be symmetry, right?
Yes, there has to be symmetry in what the charges are and like in the shape of it, right, and whatnot. Yeah. So this thing is symmetric, right? Because you have a bunch of hydrogens, right? Yeah. So they're symmetric there. Carbon's in the center. So what's going to happen is like there's always going to be like an attraction, right? This is going to pull this way. This is going to pull this way. This is going to pull this way, and this one's going to pull this way. But since it's between the same pairs of elements, like carbon and hydrogen, carbon and hydrogen, carbon and hydrogen, that pull is going to be equal for all of them. So since it's getting pulled in all of the same directions by the same forces, this is what we would call nonpolar.
It's symmetrical.
Right, symmetric, yeah.
Now, what does it mean by bond with itself? Is it bond with itself? Is that what you're asking?
Well, they're saying if like hexane bonds with another hexane, how does it bond? I guess.
Wait, is that hydrogen or hexane? The H.
So CH4 is hexane, or CH4 is what is CH4 hexane? No. Wait, because I see something here that says hexanes. What is this? What is this up here? Does this say hexanes up here, Philip?
Oh, those are just for like grass.
Because CH4 is technically methane, is what it is, right? I think that's what it is. CH4. Yeah, CH4 is methane, is what it is. Okay. Here's all the fun information on methane. Methane's the same thing that it's a gas, right? But it's the same stuff that, for instance, cows, right, when they fart, they produce a lot of methane. It's a big problem for the environment. Here's all the beautiful information about it. Methane, blah, 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 blah. I don't really say much more about it, do they? Here, let's look up, like, methane bonds with itself. What does Google want to tell me? Oh, do you have to go over, like, sigma bonds and all this stuff? Do you have to do this yet?
Yeah, I mean, we're going over sigma bonds right now.
Uh-huh, okay.
Dipole bonds, intermolecular.
Dipole, yeah.
Dipole.
Uh-huh. So this is, for instance, when, like, two CH4s bond with each other to form, like, what's called ethane, right? Yeah, this starts getting... This is where chemistry starts getting a little complicated. Sigma bond. And then what's the other type of bond called? It's sigma bonds and... One sec. Sigma bonds. Oh, pi bonds. Here we go. Here we go. This is what I'm thinking of. Okay.
Yeah, I'll go use the bathroom quickly.
You're good. You're good. Mm-hmm. 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 Let's copy this in. Dr. Gold, are we ever doing early streams again? What are early streams? Like 2 hours earlier than now? Is that what we consider an early stream? What would you consider early, Habibs? This is kind of late, I guess. This is 4 o'clock Pacific, which is 7 o'clock for you East Coast guys. I could start moving, like maybe I make Friday like an early one or something. I could start adding Friday up there.
Ooh, all right, I'm back.
Okay, cool. So this is what I wanted to show you, Phil. When it wants to pop in. Okay, here we go. So,
I've seen that before.
You've seen this before, right? Yeah, okay. This has to talk about how like things bond with each other, right? So this is an example of this is C2H4, okay? Which you know, if you're trying to figure out how, what we're getting into now are called like compounds. So we're bonding lots of things with each other, right? So this is an example of like when I'm trying to think what it is. I know it's ethene, but it's not really bonding methane with itself. Kind of is, I guess. Because another one would be, for instance, if we had C2H6, okay? C2H6 would look something like this. So we would C, right? And then H, okay? The reason why this happens is because, have we done Lewis dot structures with you yet?
No.
Okay. So... Wait, we really haven't? Like we haven't gone over like how to draw this and stuff?
Oh, that's what it is?
Yeah, those are called Lewis dot structures.
Yeah.
Oh, this is an example of a Lewis dot structure as well. Yeah. Where you just find out the number of valence electrons and then you try to figure out how do I like put them all together. Can I have a bond? Habibs, you can, but you gotta redeem 1,000 MT coins, I think, for a bond coin. Or maybe it's 2,000. I have to check what it is. Whatever the point value is, Habibs. So C2, right, this is 8 valence electrons because you have 4 from each carbon. Okay, there you go, Habibs. Yeah, okay, got you. And then H6, right, is going to give you 6 valence electrons, right? Yeah, you're good, Habibs. I see you, dude. I got you. So that's 14 total, right? Which means that you get what I say like 7 bonds per se, or 7 sticks, all right? Which when you're trying to bond 2 carbons together with 6 hydrogens, this is how you have to do it, right? Because 1, 2, 3, 4, 5, 6, 7, right? So you see how you get 7 bonds, and so this is what this would look like. If we go to C2H4, right? This is again 8 from here, and it's 4 from here, right? So this is only 12 valence electrons that you get to play with, right? Which is equal to 6 like bonds, okay? So when bonding now 2 carbons with 4 hydrogens, this is where the 6 go, right? 1, 2, 3, 4, and now you use a double bond here, right, to get up to 6. The reason why you want a double bond here is you want carbon to always have, you want each of these central atoms to have 8 electrons on it, right? A double bond means that you get to share 4 instead of a single bond, which means you're sharing 2. So that's why this is 2, 4, and then it's 6, 8 on this carbon. And on this one, it's 2, 4, and then it's 6, 8. Does that make sense why that is, Philip?
Mm-hmm. Yeah.
Okay, cool. All right. So it turns out that when these bonds happen, there's a different like sharing of the electrons that happens. So in the case of a double bond, what you have is a single sigma bond here. That's the single bond, and then you have a pi bond, which makes it a double bond. So this has 1 sigma bond and 1 pi bond on it. Okay. If we wanted to make this even crazier, let's say we had C2H2, okay? Let's say we had carbon, and let's say we put a triple bond on here, right? So it looks something like this. This would be an example of something that has 1 sigma bond and 2 pi bonds, okay? And whether it's a sigma bond or a pi bond, that just refers to how the electrons are shared. So in a sigma bond, there's overlap, right? Here between the carbons, in what we call, okay, so this is the whole, like, I don't know if you're going to go into this amount of detail about, like, you have to figure out which orbitals are overlapping. Hopefully you don't have to.
Oh, I know. We never gone over that.
You haven't gone over this yet, but you might have to. Yeah, because
they're
they're
classes before finals, so probably.
Okay, then there's no way you're doing this in the next like 2 classes. Yeah, this is more complicated. This is where like you're actually having to determine like which you know. Okay, do you remember when we were like figuring out what the electron orbital structure was of something, right?
Yeah.
When we went like 1s, 1s2, right?
Yeah, we were figuring out the rings, right?
Good, exactly, yes. So that information also allows you to figure out how the different elements share electrons. That's another thing that happens. And it also comes down to like this sp2, s, and whatever. But okay, so when they're saying bond with itself, I don't know what that means. Bond with itself. Does she have an example of what she means by bond with itself?
No.
No.
No clue.
Okay, well, here. This is methane, right? Methane should definitely be nonpolar, so let's see what it says. Right, it's nonpolar. Cool. Yes, I like that. Maybe it's what was it? This is intramolecular bonding, I think it is. There's intra and inter, right?
Yeah.
I don't think it's intermolecular forces. Oh, okay, here we go. No, this is it. Yes, okay. This is kind of what we were talking about. Okay. Do you see this here, Philip?
Mm-hmm.
So I believe these are called the intermolecular forces. Intermolecular. And these are what we call intramolecular. Let me double check that that's correct. Intermolecular versus intramolecular force. Molecules in a substance. Man, I just want like a picture of it, please. Yes, okay. Intra is within, and then inter is between the two things. So did I have that right? No. Okay. This is inter. These are intermolecular forces. And I'll come up with a cool way that you can actually remember this. Have you ever seen the word intranet and internet?
Yeah.
Okay, what is the intranet usually compared to the internet?
So internet is like. So is inter means within, right?
Yes. Well, well, I mean, Latin. I think they both kind of mean within technically. Like, what is
So it's
inter?
like, isn't it just
prefix?
like sharing?
Yeah, let's see. Inter means between. Yes, which I think intra does as well. Honestly.
Yeah.
No, okay. So inter means between. Intra means within. That's where this comes from. Okay. All right. So yes, the internet is a network that involves connecting different computers together, like around the world, right? That's what internet is. Like it's the big, like, you can think of these as all like being computers, right? Intranet is what we would call like a LAN network, right?
Yeah. Okay.
Or like, you know, computers that you have on the same router or they're on the same network switch or whatnot. So this is the whole like within, and this is the whole between. Okay. So, when we're talking about the intramolecular forces for methane, that means what's holding the carbons and hydrogens together within methane. And that is going to be the covalent bonds, okay? Now, if we have a bunch of these methanes, right, and they're kind of like all, you know, kind of sticking together and whatnot, there's what we call intermolecular forces. And that's what keeps these things, these methane particles, these methane molecules bonded to each other, right? And for methane, those forces end up being van der Waal forces. And the reason why they're van der Waal forces is because these things are non-polar, okay? So here, let me go over real quick over what the different intermolecular forces are. Types. Intermolecular forces. Cool. Yeah, here we go. Wait, I want the inter ones, not the... Yes. Yes. Right, and then London, is that the one they call van der Waal? Which one they call van der Waal? I'm always confused. Okay. Yes, okay, London dispersion forces are van der Waal forces. Okay. Here we go. Okay. So the main types of intermolecular forces. So top dog, which is what you'll always learn in anything, are hydrogen bonds, hydrogen bonding. Okay. So this is any sort of stuff between like hydrogen.
Yeah.
With
it
like
has like the dashed lines, right?
Good. Yeah. This is hydrogen with like oxygen, nitrogen. I think fluorine too, etc. There are a couple of them where like hydrogen bonds exist, right? This is what keeps like water, for instance. Water has a lot of really cool, unique properties, and that's because of hydrogen bonding, right? Not only just within like keeping the hydrogens and oxygens together in water, but in keeping water molecules together with each other. So that's what we mean by intermolecular forces. Okay, so you have that. Then you have what's called like ionic, or really what it is called like dipole. Okay. So this is when you have polar molecules. Okay. So when you have molecules that have some sort of polarity to them, like they have a positive and they have a negative side to them, then what happens is similar to like how like magnets, like magnets, like positive attracts us to the negative one. That same thing happens between different polar molecules. So if molecules have like a plus and a minus side to them, they'll start to attract to each other, like because of what's called this like dipole moment. Okay. And then what you have is basically induced dipole, which is I think that this is also like London dispersion forces. The other one they call this is van der Waal, right? It's another one. They're all the same sort of like induced dipole part. This is for non-polar molecules. And these are like very weak, right? These are like medium, and these are very strong, very strong.
Yeah, intermolecular bonds are also called London dispersion bond.
Yes.
They're
Yes.
weak and they break easily. That's what I have
Good.
in my notes.
Good.
from
Then
the
yes. Yes.
class.
Yes. Yes. Good. 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 Yes. They're a type of intermolecular bond. There are other intermolecular bonds that aren't weak, and those are the dipole ones, and then the hydrogen bonds. Okay. So, and again, this is kind of a cool thing. So if the bonding between the different molecules is very weak, then that stuff doesn't really want to hold together in a certain way. And so this is why things such as methane only really exist as a gas, right? Gases are very like spread out, and just they just move all over the place.
Mhm.
So whereas something like hydrogen, right, or sorry, water, has hydrogen bonds, which means that at room temperature, for instance, right, water likes to stay pretty close to itself, right? It's a liquid. That's because the bonding in between it is more powerful than just regular van der Waal forces or whatever. Okay, cool. Okay, so the bonds with itself here, you could just say this is van der Waals. Cool?
Yep.
All right. Okay, this one, right,
That took a
elements of
bit.
the bond. It took a little
So
bit. Yeah, well,
hydrogen,
this is one of the things with,
carbon,
like, again,
fluorine.
I know all these classes. I've taught all of them over, like, the years and whatnot, but, like, I don't remember everything all the time. I got to go back and, like, refresh my brain sometimes and be like, okay, what is this? What is this? What is this? Because, and actually it helps as the year goes on, because as I start teaching more students about certain topics as we start moving along in the year, I start remembering that stuff more, because I'm like, okay, I need to remember this. But okay. Elements in the bond here. Yes, hydrogen, carbon, and fluorine, right? HCF. Element with the stronger electronegativity. So that's going to be F, right? F is going to have the highest
fluorine's more electronegative.
Yeah, fluorine's more electronegative, right? Because it's more this way and it's more this way. So fluorine's the highest electronegativity. So this is going to be negative, right? This is going to be positive. This is going to be positive. This is going to be positive. And this is, like, also going to be negative, but, like, not as negative. Yes, Habibs, we can do yours next. Yeah. Okay. So, no charges. I don't know. What the fuck do they mean by this? No charges, partial charges, or full charges? Wait, fluorine has 7 valence electrons, right? Yes, fluorine has 7. This has 7, right? These each have 1, 1, 1. Carbon has 4. Oh, this makes sense, actually. This is kind of cool, actually. Everything here is has the full 8 on it. Fluorine has 7 to start with, and then it shares 1 with carbon. Okay. I think this has, like, partial charges on it, because you have a bunch of different charges going on. And then this one is an example, Philip. This one is going to be polar. Do you know why this one's going to be polar?
Because it's not symmetry.
It's not symmetric, right? It's very much not symmetric, right? I got hydrogens over here, and then I got a fluorine down here. This is not symmetric at all. Cool. So since it's polar with itself, what bond is it going to make with itself then?
I don't know. What do you? I need that explanation.
Okay, so here, remember, these are the bonds. This is what we say, like, bonds with itself. So something can bond with itself through different types of intermolecular forces, right? That's how, like, this methane, right, bonds with itself, right? So that can happen via hydrogen bonding, which is when you have hydrogens and oxygens and stuff. Dipole, which is when you have polar molecules. And then what we call induced dipole, or London dispersion force, or van der Waals, and that's when you have non-polar molecules. So looking at this HCF, right? This is a polar molecule. So what type of bonding is it going to have with itself? Which one of these was polar?
It's polar, so it's dipole to dipole.
Good. Yes, this is going to be dipole. So this is dipole. That's where this comes from.
And the first one, can I just say it was London dispersed?
Yeah, you can say London dispersion, or you can say, van der Waals or whatever.
Because that's the only one that he, like, told us.
Yes, yeah, that's fine. Right. Or wait, what he said? He said just call it London dispersion is what he said.
Well, he didn't. He never really named the way you say it.
Uh-huh.
He said intermolecular and in parentheses London dispersion.
Okay, right. Yeah, London dispersion is a type of van der Waals force, is what it is. So, but yes, sure. Yes, yeah. These are the ones here. So you have ionic lattice. That happens when you have like crystals, for instance. Which like diamonds are an example like that. Covalent bonding, but that's an intramolecular. Hydrogen bonding can be intra or inter, and then dipole, right, and then London dispersion. Yeah, I agree with that. Okay, cool. Does that answer your question, Philip?
Yeah.
Pretty cool one. You made me think a lot today. All right, here, let's get you a point for that. Nice, good. All right, Habibs, you here? You got a question? You want to go over Habibs? Yeah. Habibs in the chat, dude. Ooh. What the fuck is going on here, dude? The equation, like, why is there white stuff and blue stuff? I guess this is maybe just like okay. I think I see what
The value of A.
Except well, they're saying, like, for instance, this equation holds true for all values except where x is equal to something. Like, for all values, so basically, like, this holds true as long as x does not equal something. So let's see first of all how they got this. This is what they did. They did here. This is called like polynomial long division. Have you guys done polynomial long division before? Do you remember this, Philip? Do you remember how to divide polynomials and stuff?
Yeah.
Okay, so let's say we have like ax minus 2, right, is going into 24x squared plus yeah, good,
25x minus 47.
Right, good. Okay. So ax minus 2 is going to go into this 24 over ax times, right? This times this will get me 24x squared. So this is where I'm going to get 24x squared. You always got to figure out, like, okay, this times what gets me this, right? And then this is going to be this times this, which is going to be minus 48 over a times x. Very interesting. Okay, cool. Does that make sense, Philip? Did I explain that?
Like, I guess.
I guess.
I mean, I understood it because, like, I already know what I'm doing.
Yeah, you already know what you're doing, but yeah, it's just interesting. I don't know what was given to you, Habibs, in the homework. Like, whether was this given to you or you had to solve for this? Like, I don't know. Let's just prove that this is like correct here. Okay, so then you subtract these, right? So 24x squared minus 24x squared is 0. Then this becomes 25 plus 48 over a times x, right? Which, okay, in order for these to have, let's make these like the same common denominator, right? So this would be 25a over a plus 48 over a. So that becomes 25a plus 48, right? All over a. This is very interesting. So 25a plus 48 all over a. Okay. And we say ax goes into this how many times? So it's this times this gets me into this, right? Okay. So how do I... okay. But I need an A on the bottom now. Wow, this is messy. this 1 over a squared? No. 1 sec. This is 25 minus 48 over a times x. So is this 1 over 25 minus 48 over a? No. Nope. No. Come back here. This goes in this how many times? Habib says bond coins. Yes, I'll get you, Habib. I'm just trying to figure out how you do this. Yeah, this is hard. There's 25 over a minus 48 over a squared. Because then when I multiply that by, I get 25x, good. Minus 48 over a times x. Okay, good. That'll cancel that out. And then I have the cross terms, which is minus 50 over a minus 96 over a squared. Okay, cool. This cancel. So we have minus 50 over a, minus 96 over a, minus 47. What's up, Obama? What's up, dude? And then it's all of this over ax minus 2. Great. Okay. This is like the remainder is what it is. Okay. What is the value of a? So I actually don't even think we really needed to do this, honestly. I think they just wanted to figure out No, this is true. What is the value of a? I think a is going to be equal to -3. The reason why I think it's going to be a is equal to -3 because I need this first term to line up with this. Do you see how this is already? I need 24 over ax to equal minus 8x to equal 24 over a times x. So that means that a needs to equal -3. Is trigonometry hard? No, trigonometry is not very hard. Okay, so I think it's this one, Habibs. And then we can check to see if this actually plays out for the rest of them. Because if I plug in -3 into here, now I get 25 over 3 minus 48 over 9. And this is ax minus 2. Okay. Which is 75 over 9 minus 48 over 9, which is 27 over 9. Which is equal to 3, right? Oh, and it was -3, right? Plus. Yes, negative, plus, negative. Okay, now this works. Yes. Okay. And then if this works, so we get -50 over -50 over 3, or no, it's 50 over positive 3. Minus 96 over 9, minus 47. Okay, so this is 150 over 9 minus 96 over 9, which is 54 over 9, which is equal to 6. And then 6 minus 47, or it's negative. Sorry, it's negative this, right? Negative 6 minus 47 is negative 53, which is where this minus 53 comes from. Yes. Answer is negative 3, Habibs. That's... wow, that's a huge fucking bitch to do. What class are you in, Habibs? Yeah, you're welcome. But honestly, like, what? Like, this is like some really messy, like, long division that you shouldn't have to be doing at your age. In reality, like, really, we should have just stopped here, honestly. Like, I could have just stopped here. The rest of this, like, filling out the minus 3, it checks out to show that we're correct. Oh, you're just practicing for the SAT. Oh, okay. Oh, okay. All right. Well, if this is SAT practice. So, okay, here's a little general strap of the SAT. SAT doesn't require you to actually know all the things. Like, it doesn't require us to have the knowledge to go through all of this messy fucking bullshit we had to go through. All the SAT wants you to know is a bunch of tricks to be able to eliminate what are the wrong answers and which ones are the right answers, okay? And so if I was taking this as an SAT question and I just wanted to know, okay, which one of these is like just the quickest way of me being like, I'm pretty sure this is going to be the right answer, I would have just seen that, okay, I need to divide this by AX, right, and get to something which is also just going to be something in front of X. So if I look at the highest term here and the highest term here, this is 24x squared divided by AX. Has to equal the highest x term here, which is minus 8x, okay? So that means 24 over ax has to equal minus 8x, which means a must be equal to negative 3, because that's the only way I can get, right? So 24 over negative 3x, that equals negative 8x, which is what I was trying to get to. That's the way to quickly do it for the SAT, which is you're just trying to figure out. I mean, the rigorous way to do it is to then go through and divide the rest of it out, right? To go through and actually this is probably, and again that you said this is an SAT question, a lot of times with SAT, it's a lot of just like plug and chug. It's a lot of like just let me try out the answer and see if it works out correctly. So if I was doing this on the SAT and like not like actually trying to figure out what it was, but just being like, okay, I look at this, I'm like, I'm pretty sure this is going to be minus 3, right? Then I would have just tried it, right? I'd be like minus 3x minus 2, and we're dividing that into 24x squared plus 25x minus 47, right? This goes in 8 times. I get minus 24, or 8x times, right? Minus 24x squared minus 16x. Cool. Wait. Minus 8x times. Right. So this is 24 plus 16x. Now these cancel. So this is 9x. Cool, right? And then this goes into it minus 3 times. So this is, again, 9x minus 6 or plus 6, right? Cancel, cancel. 47 minus 6 is negative 53. And cool, there you go, bada bing. That's your answer, right? It's negative 8x minus 3, and then it's plus negative 53 over negative 3x minus 2, which is what this answer is, right? Looks exactly the same. What is my IQ, Dr. Gold? Oh, that's a good question, actually. I've never taken an IQ test. I don't know what IQ I actually am at, honestly. I'm decently smart. I got a PhD in physics somehow, so. And honestly, those IQ test stuff, a lot of that stuff's fucking garbage. You know, it's you know, they always have the quote, right? If you try to judge, if you try to judge a fish by how smart it is, by like how fast it can run, like it'll think it's dumb, right? Because fish can't run, like fish can swim. So in terms of like, you know, IQ, a lot of these tests don't, you know, they test like, for instance, yeah, what comparison was that? There's a quote to it. One sec. If you go telling a fish smart, run, dumb, I don't know. I forget what the. Here we go. This is the quote. If you judge a fish by its ability to climb a tree, it will live its whole life believing that it is stupid. That's where I'm trying to come from. That's so That's the analogy. So, right? If you say that someone is smart based on some test or some metric that doesn't really even like really apply to like what they're trying to do, then they're gonna think they're dumb. So like a lot of these IQ tests and whatnot, like what they test there isn't really applicable to like say like real life. Like, you know, sure you could be smart at doing numbers here and whatnot, but maybe you're like absolute garbage at like trying to teach this to anyone or trying to explain this to anyone. Then what's the point of being smart? Like what's the point of being smart if no one can understand how smart you are? So that's an example of that's why like IQ is, you know, I'm sure there's a baseline, you know, like I'm sure I would score decently high in it, but I you know, I don't know what I would actually get in that type of thing. Anyways, cool question, Habib's there. Let me give you a point here, and I'll give you another bond coin because you did redeem one. Are you the smartest of your friends? No, I'm not the smartest of my friends. I definitely have I have friends that are smarter than me. I have one friend. His name's DC. He does quantum gravity research or something. This dude's like out there. But like, again, it's one of these things where like he is brilliant, but like no one can understand what he's talking about because his knowledge is so like out there, it's so above, you know, it's in like extra dimensions that like I don't even understand. So I'm decently smart. Too smart for all of us? No, I'm not too smart. No, there's no such thing as being too smart. Okay. Cool. All right. So that's it. Okay, that's an hour. All right, awesome. Thank you everyone for joining Office Hours. That was cool. I had some fun figuring out some of those problems. SpongeBob, are you here? Do you want to play some Fortnite, dude? SpongeBob.
Yes, I am.
He says, "I'm here. I'm here for the Fortnite. I'm here for the games."
Okay, go to.
Oh, tier 2 is
Let's go to
okay. Yes. All right. Head over to recess if you guys want to come. Head over to recess if you want to come play some games. Let me I gotta one second. I gotta switch.
Yo, what's up, bro?
What's up, dude? What's up? Good to see you, dude. Here, why is my webcam not working?
Is it funny my brother plays with you? My brother's in my room playing.
Yeah, that's cool. Your brother can play. Your brother can play. That's totally cool.
Man, I'm always playing.
One second. Why is this camera not working? Camera, we want to work today. Okay, there we go. Okay. Here, let me start streaming
I'm
now.
in a game right now.
You're in a game right now?
Yeah.
Yes, good to see you, Habibs. Good to see you, Obama. I gotta raid this channel. This is always...
Why not Warzone?
What's up?
Why not do you want to play Warzone?
Oh, because this week is Fortnite. That's what we said we were gonna play. We're gonna play Fortnite this week. But here, I can...
We got a big play? Yes, sir. Sorry.
Here, let's raid. Let's start it. Ready to raid in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.